Welcome to Ask and Learn.
So I have the function in two variables, x squared times y times e to the y, divided by x to the fourth plus 4y squared. And we want to find the limit of this function as x comma y approaches the origin, 0, 0. So to do this, we can first, we can try to substitute in 0, 0 for x comma y to see if it's continuous at that point, in which case that would be the limit. So if we do that, we have 0 squared times 0, e to the 0 over 0 to the fourth plus 4 times 0 squared. And it's clear to see from this is 0 over 0, and it's thus indeterminate. So we need to use another method of solving this. So what we can do is to check if the integral even exists, or the limit even exists, we can see whether or not the limit value is the same from all directions. So what that means is x comma y is just an arbitrary point, and it can approach 0, 0 from an infinite number of directions in an infinite number of ways. And each of those ways has to result in the same z value, the same value of this function, x squared times y, so on and so forth. So if we just test out a few directions, we will be able to see whether or not they all match up. And if they don't, then the limit does not exist. So we can start by saying if the point is approaching the origin on the x-axis, where y equals 0. And if y equals 0, we can plug that in. X squared times 0 times e to the 0 over x to the fourth plus 4 0 squared. That's going to be equal to 0 over x to the fourth plus 0, which is just 0. So we found that the limit on if x comma y approaches on the x-axis, the limit's 0. Now we can try the same thing, but for the y-axis. So that is when x is equal to 0. So same thing, it's just 0 times y times e to the y over 0 plus 4y squared. And what we get here is 0 over 4y squared, which again is equal to 0. So this is looking pretty good. You know, both the x-axis and the y-axis results in the same limit. We still don't know for sure if that limit even exists. So we can try one more path. And the path we can use does not have to be linear. We use two lines, the x-axis and the y-axis, but it could follow a curve. So if we say the path follows y equals x squared, because that also passes through the origin, so that could be the path that a arbitrary point takes. So if we plug in x squared for y, we get x squared times x squared times e to the x squared over x to the fourth plus 4 x squared squared is just x to the fourth. So we can simplify this in the numerator, it's just x to the fourth times e to the x squared over 5x to the fourth, 4x to the fourth plus 1x to the fourth. And we see that this results in a different value. We have x to the fourth, these cancel out. So we're left with e to the x squared over 5. And if we then take the limit of that as x and y approach 0, here we can just substitute 0 in for x. So that gives us e to the 0th over 5, which is just equal to 1/5. And we see this value, 1/5, does not match up with the zeros we got for the x-axis and the y-axis. So because the limit is not the same in every direction, we can say the limit does not exist.